Hello friends, this is Durga again from Technology Mentor / ITversity, and as part of Hadoop application development using Java-based MapReduce APIs, so far we have seen several things. We have seen the default behavior of default mapper, default reducer, and also we have seen default input and output formats, and then we have written a simple MapReduce application to get the row count, and we have been running all these days using our Eclipse directly, and today we will be seeing how we can actually execute this application in the cluster, and we will try to understand how it actually runs in the cluster. So far we have both input path and output path on the PC where we are running the Eclipse, and it is not very straightforward to run the MapReduce application on cluster, and also it requires the data to be copied onto the cluster. So to consolidate all the steps, this slide tells us that we need to copy data to gateway node in the cluster, and then we have to load data to HDFS. So let's take care of those things. Let's identify the data to be copied, and also let's load data to HDFS. And for this we try to use our New York Stock Exchange. To begin with, we will start using cards data. I have two files, and I will show you how to copy these two files into HDFS. First, from our PC, we have to copy to something called gateway node in the cluster. Typically, a cluster will be multiple node. A Hadoop cluster will be running on multiple nodes, and few of the instances are termed as gateway nodes, and in that there won't be any daemon process like data node, name node, or resource manager or node manager. It will just have the binaries as well as the configuration files pointing to the cluster, and I will cover that later, but as of now just remember that you have to copy data to one of the nodes in the cluster, which is called as gateway node, and from there we have to store into HDFS, and then only we can actually run MapReduce application on top of that data. So let us review the data. I have the data under my home directory, and research, big data, there is a directory called data, there is a directory called cards, and then there is a directory called dex. And here you can see that there are two files. One is called a largedeck.txt file, which is 350 MB, and the other one is called deckofcards.txt, which is only 693 bytes. It's a single deck which have 52 rows in that. So let me copy this. Let me copy dex directly to my to one of the hosts in my cluster. In this case, I am using Hortonworks VM. It's a virtual machine with a single instance which runs name node, data node, resource manager, node manager. Almost all the components that are related to Hadoop cluster are running on that one node. So let me do that. In this case, I have to copy directory called dex. For that, I have to use scp -r for recursively because I am trying to copy the directory, and I have to give the directory name here. I am in the same location where this dex directory is, and then I have to give the username at hostname 192.168.225.129. This is my VM's IP address, and then I want to copy it to the home directory, which is represented by tilde, or as I'm using root, I can say like this. So whatever location you want to store, you can give the path here. After username @hostname : you have to give the location to which you want to copy the data. Hit enter. It will be copied in a moment. Now the data is copied. We will SSH to the to our Hadoop cluster, which is a single node cluster in this case. And here first we need to have a user space for this user root in the cluster, which I have which is already there. I have created that, so I can actually check by running this command user/root, and there is a directory over there. And before copying, you have to make sure that the OS user root have permissions on this directory which is in HDFS. So for that you have to run this command hadoop fs -ls /user, under which the root directory is there, and hit enter. And for directory /user/root, the owner is root itself, so this guy will be able to copy the data. In this case, this user root cannot copy to any of the other directories which are under user, because he do not have access to any of these directories. So if you are struggling to copy the files, and if it is giving permission denied kind of errors, that means you don't have permissions to write into that HDFS directory. In this case, we have on /user/root. So I will try to copy the dex directory, which I just copied from my PC into this Hadoop cluster, which is single node Hadoop cluster, and then I'm copying it into my home directory owned by this OS user root in HDFS. Remember that the source path is the local path, and this is HDFS path. And Hadoop FS is the main command which will let you interact with the HDFS. And while interacting with HDFS, we are trying to put a directory which is under our local file system into the HDFS location. Then you can hit enter. So this directory dex will be copied to /user/root, and you can validate by running hadoop fs -ls /user/root. You will see the directory dex over there. See this, you can see the directory here. So we have seen couple of commands here. One is hadoop fs -put and hadoop fs -ls. As I have explained earlier, hadoop fs is the command which will let you to interact with HDFS, which is distributed file system in Hadoop. And you can actually type hadoop fs and hit enter, and there are many commands. They follow the Linux semantics. For example, cp in Linux is also to copy in the data, and it will let you to copy from HDFS one HDFS location to another HDFS location. And we have used -put command to copy our dex directory to HDFS. And if you see the syntax, there are additional subparameters also under -put which we have not used. But after that, if you see the usage of this command, the first parameter is the local directory. In this case, in our case, dex is local directory and destination is HDFS. And after copying, we have used -ls command to list the directory. So you can go through these commands. I will cover these things eventually in my videos, but for now we will try to explore the commands as and when they are required. Okay, so now the data is copied, and you can see both the directories, both the files under dex, deck of cards as well as largedeck.txt. Okay, and now let us understand how this large deck is stored. For that, there is another command called HDFS fsck, or I think Hadoop fsck also work. Yeah, you can use Hadoop fsck, and then you have to give the path. So let us say Hadoop fsck user root dex large deck.txt, and I want to get the blocks for this file. So there is a subcommand called blocks for this, which you can see here. But to list the blocks, we have to give the command files also here. So -files -blocks and hit enter. So what it will give is it will tell you how this file is actually stored in HDFS. This file, which is logical, is actually splitted into 3 blocks with some naming convention generated by the HDFS binaries. and this, it will start with the blk underscore prefix, and then you will have the block id, and the last four characters I'm not sure what they represent. And these will the actual physical names of these blocks will have some of this information when it is stored in HDFS. You don't need to worry about all those things. And as part of our HDFS briefly in this playlist, we have seen this information even from the web interface of HDFS. So if you want to look at from the command line, you can look at here. There is a reason why I'm showing it here. So now we have seen the data. largedeck.txt is the file is of 350 MB size, and it is stored as 3 blocks in HDFS. Now we will try to run our record count program, which we have developed in last two classes or last few classes, and see how it will be executed in the cluster. So before running that, right now we have the data. Now we will start looking into how to run the code in the cluster, and then we will run the code also in the cluster. So far as part of this slide, we have seen copy data to gateway node in the cluster. In our case, we are using only one node for everything. So we have copied data to that node, and then we loaded data into HDFS using Hadoop fs -put command. Now, before actually running the program, you have to compile. You have to compile in such a way that the jar file which is generated by our Maven Eclipse on our PC is compatible with the cluster. So there are two things which you need to keep in mind. One is JDK on cluster and Eclipse should match while compiling the program, and the second one is the Hadoop jar files also should be compatible with each other. So let's review that. So to review the JDK, you can say JDK version, Java version on the cluster. It is running using 1.7.0/79. So 1.7 JDK it is using. And to validate our project JDK, you have to right click on the project and click on properties. And here it should be 1.7. So you can choose 1.7 here and click on apply, click on yes, click on OK. Now it is with 1.7, and then what you have to do is, once you change the version, you have to right click on the POM file, and you have to, what happened? Okay, I think what you have to do is, you can go to your command prompt and go to the location where your code is for this project. It is under users USD Gadiraj research big data code. So it is under users USD big data, research big data code, and then there is a directory called nysc. Here you can run mvn clean, because earlier it was 1.8, now we are changing to 1.7 so that we can run on our cluster. And then you can run Maven Eclipse clean, and then you have to build for Eclipse by running eclipse :eclipse. And then you can run mvn install. But it is changing to 1.8. Okay, let me see in my POM if there is a reference for 1.8. So even if the reference is for 1.8, even if the reference is for 1.8, when we actually build like this, and the jar will be compatible. For some reason, when I refresh here, it is going back to 1.8. I need to fix that issue. but the jar file will be definitely compatible. So when you actually run this maven install, it will create a jar file similar to this name, and this file will be in line with your pom.xml. Here it will tell you, you will give the version to which the jar file should be compiled to, and based upon that it will suffix that nysc -001 minus snapshot.jar, and this is the file which you need to copy to the cluster. So let us copy this jar file to the cluster. Okay, and here username is root 192.168.225.129. And one more thing you need to keep in mind is the versions which are in pom.xml are matching or compatible with the jar files in our Hadoop cluster. So if you see here, we have configured our pom.xml with Hadoop common with version 2.7.1, MapReduce client core with version 2.7.1, and also client common as well as yarn common. Everything is using version 2.7.1, and because of this dependencies defined here, once the workspace is built, or once you compile using Maven, you can see all those related jars here. In this case, if you look into all Hadoop based jars, they are referring to 2.7.1 because we are using the dependencies with versions 2.7.1. And these versions have to be compatible with the jars that are already available in the cluster. If not, you have to build everything together along with the jars, and then you have to ship it. If the jars are compatible, you don't need to do that. You just build the jar with your program, with the Java files you are looking for, and then you can run on the cluster. So in this case, we are taking the second route where we are only copying the code related to our Java files. So the jar file does not have any other dependencies embedded in this because we are trying to execute between compatible environments. Let me show that. Enter the password, and you can actually see. So you can go to, you have to log in first, and then you can search for Hadoop common 2.7.1.jar. You can see that most of these binaries are 2.7.1, but it has additional suffix also because these are Hortonworks we are using Hortonworks cluster, so these are from Hortonworks distribution. So the way Hortonworks works is the first three digits separated by dot are the Hadoop base version, and then the next 3 digits separated by dots is actually Hortonworks major version. So in this case, the jars belongs to Hadoop 2.7.1 and Hortonworks 2.3.0. So these two are compatible because even in our POM files we have 2.7.1, and also the binaries which are on cluster is also 2.7.1. So without any issues, we should be able to run our program even though we don't have dependency jars as part of our jar file. So before running the program, let us do jar tvf to see what we have in this jar file which is just copied, and hit enter. And you can see that it has only two programs, card count by suite and record count, and we will be using record count to get the count for large deck. So record count is a universal program. It can get the record count for any text input type of data, and in this case we are using decks which are nothing, there are two files in it, large deck.txt and deck of cards.txt, and both are of type text input format. So now let us run the command. The way you run the command is again by using Hadoop main command, and under that now we will type jar when we try to execute the MapReduce application, and in this we have to pass the jar file name, and then we have to give the class name. In this case, class name is nysc record count, and then you have to give the input path in HDFS. Earlier when we try to run in Eclipse, we have given a path in our PC or Mac. Here we are trying to give the input path in HDFS, which is user root dex large dex.txt. If it fails that input path does not exist, you have to run Hadoop fs -ls on this path to make sure that whatever path you are giving is correct. And then we have to give the output path also. The program will take 2 parameters. You have already seen that. So it takes the first parameter is input path and second parameter is output path. Here you have to say user root output large deck record count, hit enter, and then it will start executing the job. This job might fail because we miss one step as part of our program, and if it fails, we will see how we can fix that. So here it is saying class nysc record count record mapper not found. So it is not able to figure out where our mapper class is. First, we can actually do the jar tvf on our class on our jar file and make sure that it is part of the jar, and you can see that record count $record mapper, which is being compliant, is actually part of this jar, but it could not identify because we miss a line, and this line is mandatory when we actually run on a cluster. It is to set the jar, but you can hard code and give the jar file name also in this, like here, like this. You have to get the jar file name. You can hard code like this, but it is not a good practice. So there is another easier way. So the reason why it does not know is as part of MapReduce application, you can have your driver program which implements tool and extends configured can be in a different jar, and your mapper and reducer can be in other jar files. So if you want to run the MapReduce application which is there in other jar files from a class in some other jar file, it is required to set the jar file name in which the actual MapReduce application is. For that reason, we have to use this method when we want to run on the cluster. If you're running locally, everything will be together and it will work without issues. But if you try to run on the cluster, it expects that you pass the jar file name. One way to pass the jar file name is by using setjar method. Other one is by setjar by class. And here you can give the class name. In our case, the class name could be this one, record count.class, or you can actually give get class. And get class will actually return the class from which the file is from which this command is being run. So in this case, when this get class will return record count.class itself, and we can use this instead of hard coding as record count.class. We can use this, and it will at runtime it will figure out to which jar file, in which jar file this record count.class is, and it will try to set that jar to run our MapReduce application. So this is mandatory. You can right click on this, and sorry, you have to right click on the pom.xml file, go to Maven. Okay, you have to choose run as, and then click on Maven install. So choose right click on pom.xml run as, and you can choose Maven install, you don't need to go to command line every time. Only at times you might have some issues when you change the versions of JDKs and all. At the time, it's better to go to command line and run Maven Eclipse clean, Maven Eclipse and Maven install. In this case, you can we just modified the program. For that, you can just right click on form.xml, run as Maven install, and now again this nysc001 snapshot.jar is at the same location, so we can actually SCP again. And now I'm trying to run it again. It might fail because this directory is already created. So let me remove this. Hadoop fs -rm. So we are seeing another command now. So far we have seen fs-put to copy files into HDFS, fs-ls to list the files in HDFS, and -rm to delete the files in HDFS, -rm -R to recursively delete the directories in HDFS. And in this case I want to delete this directory. Hit enter, it will be gone, and then I can run my MapReduce program. Okay, so because it is refreshed to 1.8, what I have to do is I have to go to properties. So this is the problem you will get if the JDK is not matching between your cluster and Eclipse. So again I have to change it to 1.7. Click on apply, yes, click on OK, and then I can click on this, run as Maven install, and then I have to do SCP. I am running it again. Now it is running. So it is very important to match the versions between your Hadoop cluster and your Eclipse project level properties. And also while it is running, we will see other things also. So we have done all these things. We have copied the data to gateway node in the cluster using SCP, and then we loaded data into HDFS using Hadoop fs-put. We made sure our JDK and the dependencies are compatible between our cluster and our PC, and then we have compiled the program using Maven and Eclipse, which is either by command line Maven command or using Eclipse, and then the jar file is built using Eclipse itself. So when you do Maven install, the jar file will be built. Then we copied the jar file to gateway, and then we run the MapReduce application. If it is completed already, we will review the output also. So the job is completed, and once the job is complete, while job is running, you can see the progress of your job. And once the job is completed, it will emit a very important information called counters, which we will be seeing in the next video. But for now, we will just review the output that is generated. And if you remember, the location of our output is this one, user root and then the directory name. So you can actually run Hadoop fs -ls again to list. So there is one file called part -r -00000, and if you try to run a cat command under Hadoop fs, so we are looking at another command in Hadoop fs to interact with HDFS. Hit enter, and it will give the record count, which is 27,262,976, which is exactly same when we actually ran using our Eclipse IDE also. I think I have ran this program earlier also. If you have any concerns, you can also do to validate wc-l largedeck.txt, which is our input, and it has 27,262,976 records. So that being said, we have completed the cycle of copying the data and running the simple Hadoop MapReduce application against that data. As part of the next video, we will see how we can review the output of the output that is generated when we run the program, and also we will try to see other details as well. And that being said, I hope you are enjoying the content on my channel so far. If you have not subscribed to my channel yet, please do so. I will be covering many technologies than just Hadoop or big data. And also, if you like the content of the video, please click on like button. If you want to post a comment, ask me a technical question, you can leave the comment section on the respective video. That being said, thank you. Bye.